Solving chemical problems. Most of the problems that we're going to solve in this course amount to being unit conversion problems, and we can think of them that way. Dimensional analysis is a technique of problem solving where you use the units as a guide to solving the problems. I learned how to do dimensional analysis as a junior in high school physics. And looking back, I'd say that's probably the most valuable thing I learned in high school, was dimensional analysis. To be successful in this class, you need to learn how to convert units. And you're all capable of doing that. Some of you may need to put in a lot of effort and struggle with it. Once it clicks, it's going to open up a whole new world. And everything will seem so much easier in terms of doing anything involving math and units. So if you've struggled with units and conversion problems and things like this in the past, please come and get some help. I can help you. I would love to help you. I love it when the light goes on in somebody's eyes and they get it. So units should always be included in your calculation. If it's a measurement, it has a unit. If you write down the number, you have to write down the unit. Every single time, don't take shortcuts and leave the units out. It'll come back and get you. Units can be multiplied, divided, canceled out, just like any other algebra variable, a's and b's and x's. Whatever you can do with those, you can do with units. Okay, so a unit equation is just a statement, a mathematical statement that these two things are equal. The example here is 2.54 centimeters is equal to 1 inch. They are different names for the same length, right? 2.54 centimeters, if you measure it out, is exactly the same length as 1 inch. We just call them different things. They're equal. We can take that equation and make a conversion factor. Conversion factors are usually fractions. And so we can take that and we can actually make two different conversion factors out of it. So let's see how we would do that. 2.54, what? There it is, 2.54 centimeters equals 1 inch. So those things are equal. In a mathematical equation, as long as I do the same thing to both sides, it's still equal. So I could divide both sides by 2.54 centimeters. It's still equal. What's 2.54 divided by 2.54? 1. So we'd say those cancel out. That's 1. What's centimeters divided by centimeters? 1. Anything divided by itself is 1. X over x is 1. Okay? Anything. So the left side of this equation is now equal to 1. Without any unit, it's just 1. So if we multiply something by this factor is numerically equal to 1. Are we going to change the value of it by multiplying by this? No. It looks like we're doing stuff to it, but we're multiplying by 1. We could also write 2.54 centimeters over 1 inch. If I take 1 and invert it, is it still 1? 1 divided by 1 is still 1. If I take this fraction and invert it because it's equal to 1, it's still equal to 1. So from each unit equation, you can get 2 conversion factors. Any question? In a conversion factor, what's on the top, 1 inch, has to equal what's on the bottom, 2.54 centimeters. Over here, 2.54 centimeters equals 1 inch. That's what makes it a conversion factor. So most of these conversion problems take the following form. There's some information that you're given, and you're going to multiply by 1 or more conversion factors, and you're going to get the desired information. The given unit times a conversion factor where we have the desired unit on the top the given unit on the bottom. The given units are going to cancel out, and we're going to get our desired unit. So let's do an example. How many centimeters are in 12 inches? Well, we write down what we're starting with. The given. We're given 12 inches. And then we need to write down what we're trying to find. What unit are we asked for? Centimeters. So we're starting with 12 inches. We want to get to centimeters. If we know the relationship between inches and centimeters, we can go directly from inches to centimeters. And we do know that relationship. So 12 inches, this is what I call a path. This is our path or our map that tells us how to get from where we are to where we want to go. You write out the map or the path and you look how many arrows are in it. Here I have one arrow. That means I only need one conversion factor. This is my given unit. This is my desired unit. The desired unit goes on the top of my conversion factor. The given unit goes on the bottom. So I've got inches to centimeters. In the numerator here, I've got inches to centimeters. I want inches to go away, so I divide by inches. Inches divided by inches is 1, it cancels out. The units tell me, do I multiply by 2.54 or do I divide? I don't have to think about that. I put the units in, then I fill in the numbers. Well, was it 2.54 centimeters equals 1 inch, or was it 1 centimeter equals 2.54 inches? Well, you don't want to get that mixed up. It's 2.54 centimeters, that's a 4, is equal to 1 inch. So then I've got 12 times 2.54. My calculator shows me 30.48. And the unit would be centimeters. How should I record that answer? Two sig figs. This number 12 inches is a measurement. It has two significant figures. This is an exact relationship, unlimited sig figs. So what we do is you don't even have to look at it. If I start with two sig figs, then I end with two sig figs. I'm going to keep the 3 and the 0. I could write that one of two ways. I could write 30 with a decimal point centimeters, or what would be better would be to put it into scientific notation. Then it's very clear that I have two significant figures. Any questions? General problem-solving strategies. Well, first of all, read the whole problem. Then identify what are you given, what are you trying to find, and then figure out how to get there from where you are. Another way to think of that is sort, strategize, solve, and then check your work. Let's do some examples. Convert 288 centimeters to yards. Well, there's not much to read here. What am I given? 288 centimeters. What am I asked for? Yards. So I'm going to write yards over here. Now I have to figure out how to get from centimeters to yards. Off the top of my head, I don't know how many centimeters are in a yard. I could probably go look it up. What do I do know? I know the relationship between centimeters and inches. 1 inch is 2.54 centimeters. So I could convert my centimeters into inches. I do know how many inches are in a yard. There's 36. So then I can go from inches to yards. Now maybe you forgot the 36, but you know that there's 12 inches in a foot and 3 feet in a yard. You could do it that way too. It's just more steps. So this is my path. Figuring out the path, how am I going to do this, is usually the hardest part. Now I'm going to take this as a guide for writing out the actual equation. 288 centimeters. I look at that path, I see 2 arrows. That means I have 2 conversion factors, 2 fractions. I've got centimeters to inches to yards. Those are the units that go on the top. Centimeters to inches to yards. Just copying them down. Then I take this first unit, I want that to go away, I'm going to divide by it. Centimeters divided by centimeters cancels out. And then I want inches to cancel out, so I put inches in the denominator and it'll cancel. Everybody okay with that? This is the units telling me what to do. Then I put numbers in here. Well, here's our little friend, inches to centimeters. 1 inch is 2.54 centimeters. If you didn't have that memorized before, you probably do now. And then I look at this one, yards and inches, and 1 yard equals 36 inches. Be careful that you're putting the numbers in the right places. I want you to always show your work like this. Even if it's just, oh man, I know how to do that, write it out. I know it's frustrating sometimes, but that is a skill, being able to clearly write it out. And it can really save you, like on an exam. When you want to go back and check your work, if you wrote things out clearly, you can go back and see very clearly what you did, and if you make a mistake, you can identify what it was and you can fix it. Instead of just going back, I'm like, I don't know, I'm going to change that answer because I don't feel good about it. That's not very scientific. Okay, now, when we have this all set up like this, go from left to right, 288, times the top, divide by the bottom, times the top, divide by the bottom. Sometimes you might have 4 or 5 things strung together. Just go times the top, divide by the bottom. That way you don't have to worry about any parentheses or forgetting anything. 288, multiply by 1, it doesn't do anything. Divide by 2.54 times 1 divided by 36 equals. I don't like writing down lots of extra digits, so what I'm going to do before I write down my number, I'm going to think about how many sig figs is my answer going to have. 3. This has 3 sig figs. This is exact. This is exact. It's within the English system, so it's exact. So I don't even have to look at those. This has 3 sig figs. My answer has 3 sig figs. So when I write down from my calculator, I want to include at least 2 extras. So it needs 3. I'm going to write down 5. And this is just my practice. So those are the 3 that are my significant figures. And then I'm going to write down at least 2 more. And then yards. Sometimes you goof and you round something incorrectly. If you've written down a little more than you need, you can go back and make sure that you rounded correctly. Or maybe you rounded off too many digits. If I realize later, oh, I actually needed 4, I don't have to do the calculation over again. I can just look at this and say, oh, well, that needs to round up. So I'm going to keep the 4, and my digit is a 9, and so I'm going to say it's 3.15 yards. Any questions?
So you times the 288 by the 1 inch, or by the 1, and then divided it by 2.54?
Yes.
And so then you got the 113.38?
I didn't look at that result.
Oh, okay.
I string it all together.
Okay.
And then I multiply by 1 and divide by 36. And then you should get 3.1496. Question?
Besides this method, there's also one called the train method. So to make it less confusing, instead of having the x and the multiplication, you can just have a straight line.
Yeah, you can do that. Then you'd have 288 centimeters, and you'd have one long line here. And you'd have 1 inch up here and 2.54 centimeters down there. And 1 yard up here and 36 inches down there. And that is entirely fine. Remember, though, that you're multiplying by the top, dividing by the bottom. Multiply by the top, divide by the bottom. Any other questions? convert 9,255 cubic centimeters to gallons. Do this one a little quicker. So we're given 9,255 cubic centimeters, and they're asking us to convert that to gallons. We have to figure out how to get from cubic centimeters to gallons. There's more than one way to get there. Some ways may be easier, some ways may be more tedious. And when I'm driving home, I have some choices. I could take 99 or I could take 180. Or I could head north and go over the North Pole and come all the way around and come up the South Pole and come that way. Never done that one. That would be harder. Could I get there? Sure. What's easy for you may not be easy for somebody else. It also depends on what resources you have available. Personally, I don't know all the numbers I need, all the relationships here. I'm going to start with what I do know, and then I'm going to look for something. I know that I can convert cubic centimeters into milliliters. And I'm thinking I could go milliliters to liters, but I'm going to have to go look up something for gallons. So I'm going to page back through a whole bunch of slides. There. So in this table, here's some volume conversions. 1 gallon is 3.785 liters. So I got centimeters cubed to milliliters, and I said, well, I can convert milliliters to liters. This one might be useful. Now, you could use this one, but then you're going to have some other steps. So 3.785, 3.785, 3.785. 3.75 liters equals 1 gallon. Okay, so that lets me know that if I had liters, I could get to gallons using that relationship. And then I can get from milliliters to liters because I know what milli means. There's my path. Any questions? Yes?
When we're getting a problem, would you care if we started, since we know that centimeters cubed and milliliters is equivalent, would you care if we started looking at that?
I would not. So the question is, since we know that cubic centimeters is the same as milliliters, could I just like cross cubic centimeters off and write milliliters instead? Yes, you certainly could do that. There are some little shortcuts you can take. I'm going to show the whole thing because that's not going to make sense to everybody. But definitely you could do that. So here's my path. I'm going to write out my equation. So 9,255 cubic centimeters. I look at that, there's 3 arrows. I'm going to have 3 fractions. The units on the top are the units from that path. Cubic centimeters is going to go to milliliters, and then to liters, and then to gallons. To get rid of the cubic centimeters, I put it in the denominator of the next fraction. I want to divide by that. Those cancel out then. I divide this one by milliliters, so those cancel out. I divide this by liters, and those cancel out. Okay? Now it's time to put the numbers in. Always get the units in first and then put the numbers. So I've got this guy I wrote down. I'm going to use him. 1 gallon is 3.785 liters. 1 gallon, 3.785 liters. Make sure you don't accidentally switch the numbers. Milliliters to cubic centimeters, that one's easy because they're the same. It's just 1 to 1. And then this one, liters to milliliters. There are other ways to do these conversions with metric prefixes, but I'm going to show you one way only in lecture. I can talk to you about other ways, but this way always works. So to do this factor here, I need to know milli means 10 to the what? Milli equals 10 to the negative 3. So I have milliliter on the bottom. I have 1 milliliter on the bottom. I'm going to have 1. Now, instead of writing the lowercase m, I'm going to write what it means, times 10 to the minus 3. Following this pattern, you will never have 10 to the something next to a prefix. It'll always be on the other side. And the beauty of this is it's really consistent. You learn a pattern and you can just do it. Okay, so then we have to do this on our calculators. So 9255 times 1 divided by 1. Now how do I put this into my calculator? You should use the EE or the EXP button. There's a scientific notation button on your calculator. If you're not sure about this, come talk to me later, because this is important. It'll mess you up if you're using the wrong button. So I'm going to go times 1 EE negative 3, and then I multiply by 1 and divide by 3.785. How many sig figs will this answer have? It'll have 4. So I'm going to write down 6. 1, 2, 3, 4, 5. Well, I don't really run around that, so I'm going to actually put an extra one in there, even. The unit is gallons. 1, 2, 3, 4. So why 4? Well, my initial number had 4 significant figures. This is exact. This is exact. This is between the English and metric system. It's not exact, but it has, this number has 4 sig figs. So 4 and 4 sig figs, I'm going to have 4, and so I'll round this 2.445. Any questions? Units raised to a power. This is something that some students have a lot of trouble with. When you're making conversion factors for squared or cubed units, you also have to square or cube the number involved. So we know that 2.54 centimeters is equal to 1 inch. If we want the relationship between square inches and square centimeters, we have to square the whole thing. You can't just square the unit and not the number. So 1 square inch is 6.45 square centimeters. So let me show you why. So here I have a square. This side is 1 inch long and this side is 1 inch long. What's the area of the square? Well, it's the length times the width, right? It's 1 inch times 1 inch. So that's 1 square inch. You okay with that? What if I measure the sides in centimeters instead? This side is 2.54 centimeters. And the other side is 2.54 centimeters. 2.54 centimeters is the same as an inch. Then if I calculate the area, it's the length times the width. It's 2.54 centimeters times 2.54 centimeters. What is that? It's 6.45 centimeters squared. What students will sometimes do is they'll tell me that 1 square inch is 2.54 square centimeters. No, it isn't. You have to square the number. If you're going cubic centimeters and cubic inches, you have to cube the numbers. Any questions? Let's do this one. The other one is a little more simple. This one's more fun. If you want to see the previous one, watch the video from yesterday for the Monday, Wednesday class. Okay, a vineyard has 145 acres of Chardonnay grapes. Particular soil supplement requires 5.50 grams for every square meter of vineyard. How many kilograms of the soil supplement are required for the entire vineyard? And then that's a conversion factor that's given to you. Now that one is suddenly a lot more complicated, isn't it? You look at that, you're like, oh my goodness, it's just like words and stuff all over the place. There's a great meme on Facebook, and the answer to something like this would be purple because aliens don't wear hats. How many pancakes will fit on a roof? Purple because aliens don't wear hats. It doesn't make any sense at all. This does make sense though. So we read it and we're like, ah! Don't panic. Go back and write the numbers down with their units. Okay, so the first number I see is 145. So I have 145 acres. Okay, blah, 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 blah. 5.50 grams for every. Another way of saying for every is per. 5.50 grams per square meter. Well, when we write units like that, that means we have a fraction. 5.50 grams per square meter. Okay? If you travel 60 miles in 1 hour, 60 miles every hour, you're going 60 miles per hour. Okay? And then we're given this, so I don't necessarily want to write that over again, but I might just say, okay, well, that's there. Those were the numbers. What's the question? How many kilograms? So this is what they gave me, and I want to end up with kilograms. My challenge is, how do I get from this business to that? Well, they gave me two things. I can only start in one place. Question?
It's supposed to be kilometers cubed.
Oh, no, it's not. Thank you. I saw that one myself yesterday, and I fixed it, but then I didn't actually go onto the slides and fix it because that would be too convenient. Yeah, that doesn't make any sense, does it? It's supposed to be kilometers squared. Thank you for pointing that out. Yeah, I know, right? Three-dimensional vineyard. Wow. How does that work? That would make the problem really challenging, too, because you couldn't do it. So I've got two things here, and sometimes students don't know which one to start with. Well, don't flip a coin. You could, but then you might need to do it over again. Look at the units. This is just a single unit, acre. This is one of those derived units, grams per square meter. This is most likely going to be a conversion factor that's just kind of hiding. Okay, so that's a conversion factor. So when you're not sure which one to start with, pick the one that has the simple unit. So I'm going to start with acres. And I'm going to go from acres to something, and I want to end up with kilograms. And so sometimes you kind of just need to work from one end and then from the other. It's kind of like untangling a mess of string. You're starting at one end and you're like, okay, I'm stuck. Let's find the other end and go from that. And hopefully you'll meet up in the middle. Well, let's look at what was given to us. So here we have kilometers squared is equal to 247 acres. Oh, acre, that's what I'm starting with. I could use this to convert from acres to square kilometers. And you might start writing this path and then realize, oh, that's not going to work, and you erase it and start over. That's fine. Okay, so I could get there. And then kilometers squared, I don't know. Let's look at this. Oh, gram. Gram and kilogram, right? That's just a metric prefix thing. We could do that. So if I had gram, I could get to kilogram. Oh, this relates grams and square meters, right? So if I had square meters, I could use this to get to grams. And then, so this is getting to square kilometers, and that's starting with square meters. Could I do this? Yeah, we just learned how to do that. So I could go from square kilometers to square meters. Any questions? That's the hard part. It's not rocket surgery. Somebody got that. My kids like to use that one. People say it's not rocket science. It's not brain surgery. It's not rocket surgery either. Anyway, okay, so we've got our path. We just follow the pattern. We put our starting value and its unit. That's a weird S. Try that again. I look at my path, 1, 2, 3, 4 arrows. 4 fractions. 1, 2, 3, 4. 4 fractions. I already figured out the path of the units. Acres, square kilometers, square meters, grams, kilograms. I just copy them down. Then, to make this starting unit disappear, I want to divide by it. So I take the unit in the numerator and I make it be in the denominator of the next fraction. So acres cancel. Put meters squared in here.
Okay, you want to go to kilometers squared, then meters squared.
Thank you. Which is also why we write things down. So, because apparently I can't read. Acres to kilometers squared, to meters squared, to grams, kilograms. Okay. So kilometers squared, and then I need kilometers squared in the bottom. And then those cancel out. I wish I could say I did that just to see if you were paying attention. Not. Okay. I got the units to work out. Now I'm going to put in numbers. I like to do the easy ones first. This one was handed to me. They just told me 1 square kilometer equals 247 acres. Okay, so 1 square kilometer, 247 acres. Got that one out of the way. This one looks kind of icky. I want to skip that one. Grams and square meters. That's one we don't see much. But that was this rate of application of this particular soil sample, supplement, soil supplement. Okay, so it was 5.50 grams per square meter. Now some people really need to have a number in the denominator. Well, put a 1 down there. Kilograms to grams. Kilo means 10 to the 3. So I've got 1 kilogram, and then on the other side it's 1, I'm going to write the 10 to the 3 instead of the abbreviation. So 1 times 10 to the 3. It's not the only way you can do them, but it always works. I think that's pretty good. Now we have to deal with that squared thing. So we look at this, and first, pretend the square isn't there. What would we do for kilometers and meters? Well, just like we did with the kilograms and grams. 1 kilometer would be 1 times 10 to the 3rd meters. But it's squared. If we are squaring the units, we have to square the numbers. If you square the units, you square the numbers. If you cube the units, you cube the numbers. Now obviously 1 cubed or squared or quintupled or whatever is still going to be 1. But it's really important that you square this top thing. Any questions? You could. Could you take off the square here and cancel it out with this 1 times 10 to the third? You certainly could. There is some simplifying you could do. I don't necessarily recommend it, though, because sometimes you do it incorrectly. But if you like to do stuff like that, go right ahead. Just be careful. So 145 divided by 247 times 1EE3 squared times 5.5 divided by 1EE3. I'm leaving out all the multiplying and dividing by 1. How many sig figs do you think this is going to have? Three. 145 acres. That's not an exact measurement. The relationship between square kilometers and acres is between metric and English systems, not exact. This is exact. This rate of application, not exact. This is exact. 3 sig figs, 3 sig figs, 3 sig figs. The answer is 3 sig figs. And the unit is the only one that's not crossed off, which is kilograms. How should I record that answer? Is it 323 kilograms? Scientific notation is the best idea. So I'm going to put this into scientific notation. The decimal point goes after the first non-zero digit. So it's going to be 3.2, and this next digit is the one I'm going to round. I'm dropping the 8, and so this 2 goes up to a 3, and I don't record any of the other digits, times 10 to the, and the unit's kilograms, and then I need to figure out, well, how many places did I move the decimal point? 1, 2, 3. I moved it 3 places. The exponent is a 3. Now, it can be confusing. Is that a negative 3 or a positive 3? There's the whole right, left, positive, negative thing. That doesn't work for me. It's too confusing. This is what I do. I look at this number, 3,228. Is that a big number or a small number? That's a big number. How do I feel about big paychecks? Positive or negative? Positive. Big number, big paycheck, positive exponent. If it's a small number, I have negative feelings about small paychecks, then the exponent's going to be negative. Okay? So this is the best way to report that answer. 3.23 times 10 to the third kilograms. Any questions? We learned how to to calculate the density. Density can also be used as a conversion factor. And if you're not calculating the density, if you're calculating the mass or the volume from the density, I strongly encourage you to use density as a conversion factor. Do not use the density equation and algebra, because it's actually harder and you're more likely to make mistakes. Can you do it? Sure you can. But I think it's better to use it as a conversion factor. So today on the worksheet, you will have to use density to solve something. And I want you to write it out using density as a conversion factor. So let's do this example. Backpackers often use canisters of white gas to fuel a cooking stove's burner. Awesome, but we don't need to know that. If one canister contains 1.45 liters of white gas and the density of the gas is 0.710 grams per cubic centimeter, what is the mass of the fuel in kilograms? Okay, it's the aliens and the hats again. We read through it. Let's write down the numbers that have been given. So we've got 1.45 liters, and we've got 0.710 grams. Now, that has a slash for a fraction. That is so much easier to type into the computer. But when you're writing it down, you're using your hand write it as a vertical fraction. Because when you write it with the slash, sometimes you don't recognize that it's a fraction, and then you do crazy things with your units. So make it a vertical fraction. That's 0.70 grams per cubic centimeters, divided by cubic centimeters. Okay, always write those fractions vertically. What do they want to know? Kilograms. So this is another situation where they gave me two numbers with units, and I'm supposed to find kilograms. Choose the one that has the simple unit. I want to start with liter and convert liters into kilograms. The question is, how? Well, let's see what we've got here. We're probably supposed to use this, right? So this doesn't contain liters or kilograms. That would be too nice. But grams and kilograms are really closely related, aren't they? So I want to put gram here. I know how to convert grams into kilograms. And this density gives me the relationship between grams and cubic centimeters. Can I convert cubic centimeters into liters? You want to try the shortcut thing here? So I know that cubic centimeters and milliliters are exactly the same thing. Okay? So you can put another factor in here, or you can just say, instead of writing cubic centimeters, I'm going to write milliliters. They are exactly the same. So then this is milliliters. And now I have my path. So 1.45 liters, 3 arrows, 3 factors, 1, 2, 3. Liters to milliliters to grams to kilograms. Liters goes down there, so they cancel. Milliliters goes down here, so they cancel. Grams goes down here, so they cancel. The density relates the grams to milliliters, so it's 0.710 grams per 1 milliliter. And then I've just got metric things. So here, milli means 10 to the minus 3. So 1 milliliter is 1 times 10 to the minus 3 liters. That's what milli stands for. It's just like a shorthand or a nickname for times 10 to the minus 3. Over here at the end, I've got 1 kilogram. Kilo is 10 to the positive 3. So then in the bottom, I've got 1 times 10 to the positive 3. 1.45 divided by 1 EE negative 3 times 0.710 divided by 1 EE3 equals. My calculator is telling me 1.0295, and the unit is kilogram. How many sig figs? 3. 1.03 kilograms. I started with 3 significant figures. This is exact. This density, not exact. That's measured. So that has 3 sig figs, and then this is exact. So I end up with 3. Any questions? Yes? You should know when it's English and metric. Yeah. So that's actually not as tricky as it might seem. So if it has anything, any prefix in front of it, if it's got meter, gram, liter, those are metric. okay? There's a whole bunch more English units. And so you should recognize those, you know, feet and inches and things like that. If you're going between feet and inches, that's exact. But if you're within the metric system, it's exact. Really, the conversions within the metric system amount to just moving the decimal point back and forth. It's all factors of 10. And so when you understand what's going on, you actually don't need a calculator. I don't expect you to be at that level of understanding how to deal with those exponents and stuff, but you actually don't need a calculator to convert between kilograms and milligrams. It's just moving the decimal point around. But I want you to be able to write it out, because there's actually a lot less thinking involved in writing it out. Any questions? I did that one yesterday, so if you want to see that, you can find that on the Monday, Wednesday videos. Order of magnitude estimations, you can read this part on your own in the textbook. It's going to make a lot of sense to some of you. It's going to make no sense to others of you, and you can get along just fine in the class without knowing it. So it's just about doing some quick and dirty calculations. I didn't really cover this yesterday. Problems involving an equation. Some problems, like temperature conversions, you have to use an equation. Others, there's no equation. And sometimes you have a choice, like with some density problems. You could use the equation or you could use dimensional analysis. Personally, I think dimensional analysis, if you have a choice, is always the best way to go. And I'm not going to do those.